Hello, my name is Robert Smith and I'm with New River Valley Community College's Academic Assistants, and today we are looking at balancing chemical equations. For the sake of simplicity, I'm going to just refer to these as KClO3 yields KCl plus O2. That makes it just a little bit easier to follow along as we're adjusting this chemical formula to make it balanced. And it is, in fact, unbalanced, as you can tell from the number of oxygens. There are 3 in the reactants and 2 in the products. So we need to get those oxygens to both be equal to one another to make it so that this is a balanced equation, because our K, potassium, and Cl, chlorine, are the same on either side. There's 1 and 1. The method I will show you today is one that was shown to me by Dr. Adcock, and I find it to be the simplest and most effective method of balancing a chemical equation. I highly recommend that you use this method whenever you're looking to balance a chemical equation. So this is very simple. You start by drawing a vertical line beneath the yields arrow. And then on either side of the line, you'll write the species for the reactants and the products beneath their respective areas. So for the reactants, we have K, potassium, Cl, chlorine, O, oxygen. And the same is true in products. And that should always be the same for any chemical equation that you come across. It should have the same reactants and the same products. Then you write the number of each species. So there's 1 potassium in the reactants, there's 1 chlorine in the reactants, and there are 3 oxygens in the reactants. There is 1 potassium in products, 1 chlorine in products, and 2 oxygens in the products. So our choice is clear. We need to try to get both of our oxygens to be equal to one another. The method that I would recommend, and I've been told to recommend, is that you leave your diatomic species for the last bit. You save it, because all you have to do, if it ends up being an uneven amount, is to multiply it by 2 to make it even. Because you're only ever going to get a half, or some variant of a half, to get it to that, to balance. So let's look at what we need to do. Well, we're certainly not going to start with our products, because if we're saving the diatomic for last, we could adjust the KCl, but that doesn't really help us because potassium and chlorine are the same on both sides. So let's look at the reactants instead. We're going to change this to a 2 and see what that does. You can play around with the numbers, but generally you're going to want to try to see look at your oxygens, and in this case there are 3 oxygens. What does 3 and 2 go into? 2 being the number of oxygens on the product side. Well, they both go into 6. So all you need to do is start by multiplying that whole reactant by 2. That's what the coefficient is signifying. So that changes our number for each species in the reactants column. Potassium is now 2, chlorine is 2, and oxygen is now 6. So now we've made things what seems to be a little worse, but it's easily fixed. If we put a 2 in front of the KCl in our products, then that changes our K and Cl to 2. And now our potassiums and chlorines are the same on both sides again. And now we know why the diatomic molecule is saved for last, because all we have to do is multiply it by 3 in order to make the total amount equal. So 3 O2s makes it 6 total oxygens, because there are 3 diatomic oxygens there, and each diatomic oxygen contains 2 oxygens. 2 times 3 is 6. And now you'll see that our numbers are the same on both sides of the equation. We have 2, 2, and 6, and 2, 2, and 6. So we can come back and write the balanced chemical equation, which is 2KClO3 yields 2KCl plus 3O2. If you use this method every time you do a chemical equation and trying to balance it, you will be successful.